Hello everyone, this is Dr. A. Chaitanya Krishna. Welcome to Cynohub. Here in this video we are going to explain the spherical capacitance. Before going to that one, before going to the spherical capacitance topic, first of all, what is mean by capacitance? In the electromagnetic field, what is the definition of the capacitance? The definition of the capacitance is C equal to Q by V. Here V is the potential, V is the potential, is the capacitance is the ratio of charge enclosed by the two plates to the EMF induced in that plates. EMF induced in that plate. EMF or potential induced in this plate. That is C is equal to Q by V. According to our electrostatics, this Q we can write by using the Gauss law. We can write as a epsilon into closed surface integral of d dot ds. Closed surface integral of d dot ds. And we can write in terms of E dot dl. In terms of E dot dl. This is also a closed surface. Means here wherever we can find the capacitance circuit must be a closed circuit, not a open circuit. It must be a closed circuit. Based upon this one, and one more doubt is there. Whenever we can write as a potential, potential equation is V equal to minus closed line integral of electric field intensity. But here minus sign not indicates. Why? Because here in this one we can find the potential is absolute potential value. That's why the potential value must be a positive. That's why only we will not denoted as a minus in front of E dot dl. This is about the capacitance. Now in this capacitance, based upon the capacitance, we have to find the three types of capacitance. One is a parallel plate capacitance, coaxial capacitance, and spherical capacitance. Whatever that one, we assumption must be a based upon these two equations, integral E epsilon into integral d dot ds, integral E dot dl. In this one, the third and important one is the spherical capacitance. This spherical capacitance, why we can explain this spherical capacitance means in the JNTUH question paper, previously we can see that question paper. In that, the very important and frequently asked question in the capacitance topic is the spherical capacitance only. In this spherical capacitance, we take a spherical capacitance in an inner sphere and outer sphere. Inner sphere with a radius A and outer sphere is radius B, and the condition is B is greater than A. B is greater than A, and we have to find this is the 2 and this is the 1. Means wherever we can find the integrations, 1 to 2 we have to find the integration. That's why we have to take an as a 1 and 2 here, and the condition is B is greater than A, and that means the inner conductor radius is A, outer conductor radius is B. Based upon this one, we have to find the what is the capacitance. Based upon this one, we have to find the what is the capacitance, and this capacitance we have to find these all are A and B as a radius in a spherical coordinate system. That's why we can assume that this coordinate system must be a spherical coordinate system. In the spherical coordinate system, we have to find C is equal to Q by V. Now we have to find what is a Q. Q equal to epsilon into closed integral of d dot ds. Now here we can write as a one more thing, we can remove this one. Why? Because according to Gauss law, is a Q is equal to integral d dot ds only. Integral d dot ds only. If we can write as a epsilon in place of the compulsory, we have write as a epsilon into E. Here integral d dot ds, this we can write as a integral d dot ds. We can take as a surface integral as a direction should be a r direction. Means surface integral in r direction. Surface integral in r direction we can take, and surface integral in r direction means d component should be in r direction only. R direction only in ds. Here this in r direction, this should be in r direction, means surface integral, we will get it as a 4 pi r square into dr. 4 pi r square into dr. Why? Because the surface integral at r direction, the surface integral at r direction should be equal to 4 pi r square. 4 pi r square. For example, here from this equation, we will get it as a ER is equal to, instead of D we can write as a epsilon into E. Epsilon into ER. Epsilon into ER, that's why we will get as a Q by 4 pi epsilon naught into R square. Wherever we can write as R. If we can write as a E, means in generalized equation we can write as a Q by 4 pi epsilon naught into R square AR bar. Here this should be the E value. Now we will get as a E value here. E value here, in this E the Q value is also there. E value Q is also there. Then we can substitute in the V equation. Now V is equal to integral E dot dl. Integral E dot dl. Here L length also, differential length also we will take as in R direction. Why? Because E we will find in R direction. Then E dot dl also we will find in R direction. That's why we will get as a V equal to integral of Q by 4 pi epsilon naught into R square into dr. And limits also, here we can write as a line integral from this to this one. That's why we will write as a B to A. Integral should be the B to A, minus to plus B to A. Then here in this equation, we will write as a equation, this is the capacitance equation, we can find the absolute value only. Where we can write as a potential equation compulsory we need to take as a minus symbol compulsory. Then V is equal to minus integral Q by 4 pi epsilon naught into R square. In this integral, we have to write as a V equal to minus Q by 4 pi epsilon naught into B to A 1 by R square into dr. 1 by R square into dr. This integral we will get as a minus 1 by R. Whenever we can get as a integral, 1 by R square into dr should be a minus 1 by R. Minus 1 by R means here we will write as a minus into minus plus. We will get as a Q by 4 pi epsilon naught into 1 by R limits B to A. Then we will get as a V is equal to Q by 4 pi epsilon naught into 1 by A minus 1 by B. From this equation, the C is equal to Q by V. Then from this equation, C equal to Q by V. That is equal to 4 pi epsilon naught by 1 by A minus 1 by B. This is the spherical capacitance value that depends upon the inner radius and outer radius of the sphere. This is about the spherical capacitance value. In coming videos, we will discuss more about this capacitance value. Thank you.